right. Thanks for joining this morning. Good morning, good evening, good afternoon, depending on where you're located. My name is Jim Webb. I am the director of EPM applications at Baker Hughes here in Houston, Texas. And I'm excited to have this opportunity to present this topic. It's very near and dear to me. You'll learn throughout this presentation why that is the case. But if you haven't had a chance to connect with me, I put a QR code on the screen, and go ahead and connect. I have over 1,500 connections on LinkedIn. It's almost like my baseball card hobby. I don't want to say that I collect connections, but I reach out to as many people as I can and try to provide free content, provide advice, and so forth. I've been in the EPM, or the enterprise performance management space, longer than I like to admit. I actually built my first S-Space cube in 1997, and the rest is really history. I've worked for everybody along the way, as you could see from my LinkedIn profile. So let's go ahead and get to the show. My purpose today with this particular topic is really, this is a very highly accelerated masterclass in that joining, if you will, between the data science world and the finance department, and to help you begin to think about how you can find that intersection between finance and data science, specifically as it relates to people and technology. This is an art of the possible presentation. Some of it you'll see is going to focus on content that is already available. And then I'll also talk about capabilities that are on Oracle's radar. If you had the opportunity to listen to Matt and Hari in the keynote, you'll see some similar themes, but I'm going to take a little bit of a different twist on how I would approach some of those future state capabilities. And then I'll talk about some things that are really important when you want to implement an analytic solution or a predictive model as it relates to enterprise performance management, how you can start to build a conceptual architecture, but also a framework for managing your ideas from inception all the way through running it into production. For the first time, I'm absolutely happy that I can say that I'm not here to sell you anything. I'm not a consultant. I have retired from consultant. I've been happy out of the consulting world for almost a year now. So you can't blame me for anything that I show you as, oh, you're just telling me this because you want to sell me a project. That's not the case. I am here just with the simple purpose of sharing ideas and starting a conversation. So if you had the opportunity to link with me on LinkedIn, we can continue this after the show. So I came up with this idea, this topic idea, probably about 2.5 years ago. What would happen if the CFO and the data scientists met for lunch, and what would they talk about other than the fact, do you like balsamic vinaigrette? Are you a ranch person on your salad? And I want to do some character development here on this screen. Yes, this is the best that iStock photo could give me as far as two people in front of a computer over a lunch. Don't take this the wrong way if you're in finance, but the older gentleman on the left side of the screen, that's your CFO. And then the really young, attractive looking guy with a really cool watch, that's your data scientist. So yeah, I wanted to do a bit of a character development, but the original reason why I'm here is I received an email about a month ago from the folks at NRL reminding me that I did a presentation back in 2007 at the Hyperion Solutions Conference. I didn't even remember that presentation, to be honest. It was something along the lines of near zero downtime reporting using transparent partitions. And then I just begged when I saw the request, can you bring this up to date, to say, can I do something different, something that's more meaningful to me? And this is where I was able to bring this presentation back to life. So as we did the character development for the chief financial officer, we need to first develop a problem statement. This is a story that we're going to work through today. The CFO has a list of problems that he's trying to work through in his organization. And these problems will probably resonate with you in your jobs. One is there are organizational pressures on the finance department, pressures from the top, from the board, from shareholders to provide better insights and also provide better predictions about the state of their organization in the future. Organizational pressures around just business processes that are not optimized and the speed that their competitive environment is changing and being able to react to those changes. Resource shortages are another challenge facing the Office of Finance. You know, if you think about the way that we described a finance professional, say 5 or 10 years ago, and the way it should be described today, it's completely different. Of course, there is a core baseline in finance knowledge needed, but with the kind of popularity, if you will, of analytic capabilities, the data management capabilities, the ability to wrangle information and provide, you know, better insights on forecasting, that requires a different set of skills. And often those skills come at a price that present specific budgetary constraints or challenges on an organization, because I will say that your data scientists are not going to be, or those finance professionals with a data science background are usually not the what you would describe as the most affordable candidate in your short list. Data and technology challenges. We have been battling data cleanliness since the invention of the byte. And I don't want to say that I was around back then, but this is a consistent issue, is constantly evaluating the quality of data, evaluating the meaningfulness of the information that's being collected at such a rapid pace is very important. And then understanding that the amount of data that's coming into an organization is so vast and coming in at such a high rate of speed. Do you have platforms and you know, the people to be able to understand, consume, and scale to the needs of the organization, scale technology needs? And then, oops, going the wrong way. And then the next one is, as finance is finding that they have such pressures, all of these factors really put pressure on their ability to build trust and build credibility to their stakeholders, to the people that they serve within the company, not only the board of directors, but if you're in a multinational organization like, say, Baker Hughes, you have product companies that you're working with and leaders within the product companies. You may have geographic leaders, product line leaders. You may have customers, you know, customer leaders, sales leaders, and so forth. Being able to be a partner to those different groups and provide better insights with the data that you're collecting. And quite frankly, everybody's asking finance to do more with less and do it faster. So with all of those challenges in place, the CFO is going to ask the data scientist to help them, at least initially as they start this lunch, to answer a couple of questions. First, how can the concept of data science help finance identify new sources for talent? And then secondly, how can you understand, or can the data scientists help the CFO understand, what do we have available today that we could use to start addressing these challenges? And let me preface these questions with one simple thing. You need to help us answer all of these things that we understand and know as we're building our plans for the next year, or running our performance management cycles. Make sure that anything that you tell me is scalable with one thing in mind. All of the assumptions that go into any decision that we make, everything can change with one sneeze. I think everybody on this call can understand this concept. So from a spend, from resources, the flexibility of hiring new resources, we need to understand that every assumption that we held yesterday can change today. So now it's time, CFO sits back, takes his first bites of his salad. Now it's time for the data scientist to take over in this conversation. And First, it's to level set and say, let's look at some of the things that data scientists or data science or analytic professionals, if you will, some of the problems that they help organizations solve. First is identifying themes in data. And themes could be simple as asking or answering a question about identifying specific trends in the data that might be trends that look at seasonal characteristics or other type of characteristics that are important to the organization. When you're looking at trends, one of the important, kind of objectives is what's unusual as I look at the trends of data. Why would something be higher or lower than expected? Looking at then, well, I have the data, I know the anomalies or the outliers. What's the likelihood that a certain event will or will not occur? So predicting likelihood is another problem that data science is targeted to solve. Highlighting relationships, and this is where, not to get too deep into the data science speak, but this is identifying correlations in the data that may not have been readily apparent. I like to use a little story of, that there is in the city of New York when during summer months, when ice cream consumption increases, so does crime. But that's not to indicate that there's a correlation between ice cream consumption and crime in really anywhere, but specifically New York City. The real correlation is probably you're eating more ice cream because it's hotter and people are not working as much or they're more agitated. And that's likely the reason why crime increased. The fact that there's more ice cream that's being consumed is not necessarily a correlation. So don't confuse the terms of correlation and causation. And then the next step is, once you have your data sets, then you need to begin to understand how to categorize data and look at things from a marketing analytics perspective is one great example. How can we categorize the information that we're receiving so that we can then focus on certain areas of data without having to look at the entire population? And then once we go through, this is a representative set. There are so many questions that data science can answer, but I have a list of questions that are important to answer. Then how can we use machine learning, the technologies to learn from previous experience and repeat the process and do that in an automated fashion and then improve as we're doing that analysis? So that's a level set for the CFO. Hey, these are the things that data science typically can help, but let's go back now and address that specific question you had about how can we help you identify new sources of talents for the finance organization? And the first question is really simply, and this is where you bring your HR professional into the conversation, have you performed an analysis of career profiles? Meaning, have you looked at the career profile for a financial analyst? Let's look there first. And in three categories of education, core skills, and what are the questions that a financial analyst really seeks to answer, you have that set of information, but then you really want to compare that against what's typical for the data scientist. And there are certain things that I want to highlight. Let me see if I can get the pointer options and get my highlighter out. What's really, really important, oh, not highlighter, let's do laser pointer instead. Communication is a cornerstone for a financial analyst. Their job is not complete when the numbers are on a report. Their job is really complete when they deliver that information to their stakeholders, the person that asked for that data, whether it's a report, being able to communicate, hey, this is what this information is trying to tell us. So communication for a financial analyst is critical, as well as critical thinking, understanding what is the outlook for our organization based on these financial statements. That's very similar to some of the core skills. If you look down this list, you'll start to see maybe a little bit of a variation, but a lot of the skills are transferable, if you will, between data science. Accounting and finance is another form of math where you see multivariable calculus and linear algebra that's important to a data scientist, and even statistics. Being able to program for the data science, take a data set, massage it, clean it, and then make it available for analysis. And some of we refer to that as data wrangling. Now, I'll stop for a moment and say, too much data wrangling probably happens at the financial analyst desktop. And as an IT professional, that's one area where we like to help them reduce that amount of data wrangling that happens, but that is in the sweet spot of the data scientist. Now, if we merge the financial analyst skill sets and the data science skill sets, we create a new role. And this is what I like to describe as the finance analytic professional. And the education, of course, is you'll see this as you're looking at the students that are coming into the market even today. They have dual degrees in economics, finance, accounting, statistics. They have minors or dual degrees, as I said, in technology or math, specific maths. They have all of these core skills and then some. The ability to be naturally curious about solving problems, a high level of awareness of the business that they're working in. Not just I can take orders and I can act on those orders. They really understand. I will say that from the financial analysts that I've worked with, the analytic professionals, I should say, that I've worked with, it is very important for them to truly not only understand their programming skills, understand the financial or an accounting background, but have an understanding of the business itself. The questions that the finance analytic professional answers is all of those questions. Now, here's the trick. And since it's still baseball playoff time, and because we're all enterprise performance management professionals and analytic professionals, I'm going to steal a line or a subset of a line from one of our favorite movies, Moneyball. You're probably going to have to build that finance analytic professional role in the aggregate. If you remember back to Moneyball, they're trying to replace a player that left the team. Well, they had to replace that player with 3 players. And I would say that at least to start, you may consider replacing or building that finance analytic professional with multiple skill sets that are working together, or multiple persons working together. So now we're going to go back, as the data scientist is allowing the CFO to continue to eat. Let's look at what you have in the technology portfolio today. And specifically to answer the question, how can we use historical data to predict the future? And I'm not only going to do that analysis or give you the examples, I'm going to compare the quality of the answers that are coming out using a second set of tools that a data scientist would use to judge the quality of the predictions. And then later on today, we'll talk about, that next level learning. How can we use machine learning to analyze deeper sets of data? But let's first look at, everybody has this. If you're an EPM cloud planning customer, you have predictive planning available to you. It may not be enabled, but it's there. It's actually been around for quite a long time. So what is it? Predictive planning is, of course, I love my little build slides, but it is a capability. It's a feature of Oracle Cloud Planning, and it provides that ability to do time series analysis based on the historical data that you have in that planning cube. And I'll talk about why that's good and why that might cause a few issues when you get really excited about using predictive planning. But let's talk about the positives first. It's really, really helpful also when you want to validate forecasted values. One of the best use cases of predictive planning is to basically judge that, as we're creating forecasts into the future, well, how close were the human entered forecasts to what the machine is predicting, and find out if there are any lessons that could be learned that might help us improve the human generated forecasts. That one of the key points in that kind of learning is the acceleration of what I like to call anomaly detection. We'll talk about outliers here in a few moments, but anomaly detection is truly using the machine generated predictions to identify somewhere out in the future, if I backtest my forecast to say, what happened here that I didn't really, that the machine predicted a certain growth area, but what really happened was way outside of the confidence intervals, if you will. That's an important step in validating the accuracy of your forecasts. And then, of course, the more data that you throw at a prediction, theoretically, the better your predictions will be. And we'll talk about the pros and cons of throwing more data into your cloud planning application. So to do this, we're going to look at two types of models. We're going to look at a non-seasonal model, and then we'll look at a seasonal model. And in fairness, I will say that the seasonal model that you're looking at, or sorry, the non-seasonal model, and even the seasonal model later, these data sets represent two different companies, real companies, but I decided to anonymize the data sets. And the idea here is we're going to put this data, or I have already put this data into a cloud planning application based on quarters and just a single measure or an account, if you will, domestic revenue. Now, I know from this data set, which is real life data, that there are certain values, as you can see, some from 2018, Q1 2018, all the way to Q2 2019. These values really did occur, but I'm going to use those 6 elements as my holdout group. I'm not going to put those into the model. We're going to use that future data that really happened as a test to see how well does the predictive planning capability, how well does it make a prediction? So let's get started with that. So if you've never used predictive planning, let me walk you through some of the key pieces here that are really important to understand. Let me make sure I got my cursor. First one is when you run a prediction on a data set, you first receive this, behind the scenes, it's quite amazing actually what's happening. It's running probably about 12 iterations of models, but actually it's running hundreds and hundreds of models in the background. You're probably, unless you understand data science and understand the selection criteria for either selecting a seasonal or non-seasonal prediction method, you don't realize that it is going through many, many, many different models to select the best. Now, as we look at the charting capabilities, what you see on the left side, this green bar shows me what had happened. And if you hit outliers, or those unusual events, as I like to see, this line will color differently. I believe it's an orange color. And one of the neat things about this predictive capability is it will handle outliers for you. One of the bad things about this predictive modeling capability is it will handle outliers for you. I'll come back to that point in just a minute. Going forward, this is what I like to describe. I live in Houston, so you can understand where this is coming from, particularly with a summer full of hurricanes in the Gulf. This is the cone of uncertainty as we're forecasting. Imagine if you see all of the lines of where a hurricane could potentially hit the coast, the Gulf Coast. You see all of these different line charts, but then you see when the hurricane is far away from the coast, you see this large cone. They call it the cone of uncertainty. This time series modeling, or this predictive planning modeling, is very similar to that idea of when I'm far away from an event, I can give you a confidence interval range of, in this case, worst case is 2.5% from the true predictive or the trend line. Best case is I'm 97%. So that's why you see the cone, if you will, of the predictions. Some of the historical data that we're looking at. I have 28 observations in this data set, and there are no outliers. But if there were outliers in the data set, and an outlier means it's a certain range above or below that prediction or that confidence interval range, the predictive planning capability in Oracle, it will handle those. It'll smooth those outliers out. I want the ability, this is my request back to product development, I don't want it to do that automatically, because an outlier can tell you a story about your data that you may need to understand to adjust your prediction. And we'll keep focusing on that. The other thing that's really interesting, as it's going through all of those models behind the scenes and it's trying to find, hey, what is the best model that we could present? And this one is an autoregressive integrated moving average, or an ARIMA 0 to 1 PDQ. Now, you don't just naturally know those things. And I wouldn't expect a financial analyst to be talking in terms of autoregressive or moving averages. Well, that's kind of easy to understand, but an integrated moving average or an autoregressive integrated moving average, those prediction methods, if you don't understand them, you're going to have to take some time, as my recommendation, to research exactly what is the math behind the prediction method. And also, when you talk about the error message, the root mean squared error, wow, that's a mouthful. There are so many different methods for using to predict the goodness or the badness of a model. One of the questions I have here is a higher number of RMSE good or bad? Should I hope for a high RMSE or a lower one? You want a lower number. The lower number basically says that if you think about a trend line over time and the prediction, or cone of uncertainty, if you will, they represent different points in your prediction. And as it's going through and analyzing the distance between every predicted value and what really happened, you then are able to, and I'm simplifying the heck out of this description, but then you're able to develop a measure of goodness, which RMSE is one. And other tools that you'll see in just a moment, the AIC or Iki criterion is used. You have, if you're a Bayesian statistics person, then you may use the Schwartz-Bayesian method. There's 100 different criterion that are used. RMSE is one, but here's my problem with that. How do you explain the goodness of fit? And with it just picking one measure of a goodness of fit, sometimes to a data scientist that raises a red flag. So I went ahead and applied the prediction to my little simple model. We're still in non-seasonal mode, and you can get an Oracle solution salesperson to walk you through this. It's real simple to do. Apply the prediction, and now what we're going to do that's unusual is I'm going to use a tool that I love, which is called Jump. Jump is manufactured by SAS, and I told you this, I'm not selling Jump. I just use it because over the last 2.5 years in the Masters of Science and Analytics program at Texas A&M, we used Jump quite extensively to analyze data sets. It serves as both a data visualization front end, but it also allows us to do different types of regression modeling, time series modeling, you name it, Jump can do it. And it's a very graphical, easy to use piece of technology. And of course, if you go out to their website, you can try it free for 30 days. Otherwise, it's, per seat is quite expensive. So what did Jump say with the same data set? Now, this is where it gets really fun. This is the data scientist view. You do get the same time series diagnostic revenue. As you can see, as it's growing over time, I expect that. You get a certain range of quality measures that, if you're not familiar with these, mean you should understand the number of observations and so forth. But then you get two different type of diagnostics. This is what Oracle is doing behind the scenes for the person using predictive planning that a data scientist would, quite frankly, do by hand. One is interpret the autocorrelation function. You want a model as much as you can that shows a very well-defined pattern. Okay, that kind of gives me an indication that this is a good model to work from. The other is the partial autocorrelation function, where I see that there's a significant drop off between lag 1 and 2. These things, as you get trained in data science and you get trained in deeper analytics and statistics, these mean things. This starts to tell me whether I have an autoregressive model, a moving average, an integrated moving average, or if I have an autoregressive integrated moving average. Well, we're going to cheat because Oracle Cloud Planning already told us what it thought the model should be in ARIMA 021. We're going to plug in those same values into the jump tool, into the autoregressive order, into the differencing order, and into the moving average order. We're going to reset the prediction interval so that it matches what we have by default in planning. And then we're going to generate a model. And jump generates the model quite quick. And quite frankly, it generates a model that's an integrated moving average 2-1, which technically is the same thing as an ARIMA 2-1, but it also gives me the prediction range at every point. And unfortunately, I wasn't able to expand this screen. It also gives me the forecasted values. Also, as I was mentioning earlier, it does not. I would have probably considered this particular item in the data set as an outlier. Well, jump doesn't handle outliers automatically. I have to make a conscious decision to go in and handle outliers. Once I'm through with the jump analysis and I can generate the forecasted values, then I can do something quite interesting. Let's do a little comparison test between what Oracle Cloud Planning showed and then what jump showed. And we're going to use that on my holdout set from the forecast range of 2018 Q1 through 2019 Q2. Something interesting is occurring here. If you look at, these are the values that Oracle Cloud Planning predicted. And here's your difference, not necessarily your residuals, but it kind of is your residual between the actual value and what was predictive. It gives you a difference. This column here is the jump predicted value and also the residual, or the differences, I like to call it, between the predicted value and the actual value. And you'll see something kind of interesting. Both of these tools, well, if you wanted to pick a winner, it's a draw. Why? Because they're both equally incorrect when it comes to this particular data set. And what I mean by equally incorrect, that's actually a good thing. To a data scientist evaluating the quality of this prediction, I don't want one tool to be so far off in left field and the other one that I can't explain why their matches or their predictions are so far off. They're actually very, very close for this particular data set. So by saying that, I'm giving you the confidence, I should give you the confidence that the method that was selected by the Oracle Predictive Planning is almost spot on, with the exception of a couple of points here where they're off a little bit, but it's exactly what a data scientist would have come up with for this non-seasonal data set. So we'll take a moment. I think my next slide is, we've basically, the CFO is like, his mind is swimming right now. And he's trying to say to you, the audience, hey, does anybody have any questions? So let me do a jump out. That was a lot of information. I know this is a master class. Let me see, we do a little time check here to the Q&A. Do we have any questions? No open questions. That means I'm explaining everything in a spectacular way. That's the way I'm going to take that. So let's go back. Since there are no questions, let me see if I can get us back to presentation mode. Robin, you're still there? Am I still showing the presentation?
Yes, you are.
All right, so that was a lot. I'm rushing, I know. So I'm going to take my vintage Hyperion cup of water here and take a quick drink before we get into the second half of the show.
That's awesome. And you did get a comment that the RSME explanation was super helpful.
Well, trust me, I would encourage you to go and do a lot of research on that, RMSE, and it's actually more used in regression analysis than in time series. But regression analysis and time series are closely related. Just consider time series is a bunch of regressions that are happening over and over and over as you're moving forward. So yeah, I appreciate that feedback. So if everything's good, we'll go quickly, far more quickly through this one. Let me get rid of me off of the screen. Hopefully, if I can get back. Zoom is not my forte these days. Teams is my forte. So let me get myself out of the way. We'll go through a second model, a seasonal model. And I will say personally, I believe that the seasonal capabilities, and holds true in both predictive planning and in other tools, Jump, SAS proper, R, and Python, regardless of what you select, seasonal models are far more interesting. Why? Because there's a lot of movement. You remember as a kid when you're riding in the back seat of the station wagon with the folks down the road and you would do this out, with your arm out the window. Well, that's what seasonality feels like. You're doing the ups and downs for your charting. Same approach as last time. We have a range of data for this time is an airline. And we have a holdout set from 2016 to 2017. Same output, but you start to see some differences in the seasonal model output that you didn't see in the non-seasonal. What's really cool is it's telling you the seasonality range of 4 quarters. And you see that by the seasonality here. That's good because I have quarterly data. If it's truly seasonal, then, or on an annual basis seasonal, I should say, I should see groupings of 4 in the bands, and I do. And it continues to hold those patterns, not only for the seasonality as it's working forward, but it also holds the growth that you can see in this data set as well. What you also should notice as you're looking at this cone of uncertainty, it gets really wide the further out into the future that you get. I forecasted the same, time period, or I should say, I held the same time period. So, you also are going to see, if we went back to the other one, I think the accuracy is a little bit lower here than it was on the previous one. But in this situation, it being predictive planning, did understand that the data set has seasonality. That's the S at the beginning of the ARIMA, seasonal, autoregressive, integrated moving average. And you get 2 bands of numbers, capital PDQ and a lowercase PDQ of a 0, 1, 1, 1, 0, 0. If you're a finance person, you never have to know about that. I'm not going to go in that today. If you want to really get into that, talk to me, connect with me on LinkedIn, and I'll bore you to tears about what all those numbers mean. But it was also very easy to generate the forecast using predictive planning using that data set. We did the same exercise here with Jump to look at the data set. Okay, so Jump's graphing, I will say, is kind of meh. It's not too great, but you can kind of get the idea that it's seasonal and it's growing over time. The autocorrelation function and the partial autocorrelation function, I will tell you that if I were going to respond to this chart in a test, as I was getting my Master's of Science in Analytics degree, I'd probably say, this is messy. It gives me a decent prediction, but I'd really be concerned about the prediction just based on the kind of the sinusoidal, the damped sinusoidal characteristics here. And you get some really, really funky looking outputs here, but the one you should pay attention to is that differencing order at lag 4. Not really certain why it didn't pick lag 4 other than the fact that you are beginning to see the seasonality. When it gives you that little hump there, it's an indication there might be seasonality in the data. Again, to a finance professional, analytic professional, this is deep science here. You don't have to worry about it, but we're going to plug in all of the prediction parameters, if you will, from the method chosen by Oracle into our Jump model and look at the output. And again, you do see that it's a valid selection. And the reason why I see that it's a valid selection of a model is simply by the summary. It says it's a stable model. Yes. Okay. I feel a little bit comfortable moving forward with this type of model without having to explain some of the goofiness in the data. But here's the proof in the pudding is when you actually have a holdout set in your data. Let's look at what Oracle Cloud Planning predicted, and let's look at what Jump predicted. And you'll see something that's just really, really amazing. Based on that set of observations in the past, Oracle Cloud Planning was 32 units off in its prediction from what really happened. That was holdout. Jump was 16 or almost 17 units off. Then you get down to 6 quarters out into the future. Predictive planning did a pretty darn good, made a good guess, I would say, with this data set to say, you're only 1 point off. This is why I like using predictive planning and I love seasonal models. If you trained them really well and you continue to use these type of approaches of back testing, then you can see, well, during these quarters, I'm off, but it usually returns itself to a righteous state. It looks good. So what are the takeaways? There's no clear winner between the two tools, but your confidence should be much higher in the Oracle predictions, just simply because in this one, they're not directionally incorrect. They are directionally correct. As far as I'm concerned for making predictions for a seasonal model, I would be comfortable using these forecasts. Now, one thing that really, really is important, and I don't really have, I'm doing a time check. I don't have a lot of time to dive into it, but there are a lot of things that you should know about the data before you start making forecast decisions. So let's summarize this real quick. Predictive planning is good for starting point for predictions, doesn't take much effort, and it's good to do a sanity check. However, if you're not comfortable explaining things like goodness of fit or root mean squared error, I wouldn't tell you to go bet your career on your forecasts. Make sure that you do some homework, and it's not a substitute for sound business knowledge. So how do you take this to the next level? And I'm going to apologize up front, Robin. I'm probably going to need about 5 over my time, but I'm going to wrap this up as quickly as possible.
That's fine. Take your time.
Okay, so the company implemented a big data lake. You'll see a lot of parallels. If I've had some Baker Hughes colleagues on here, yes, we have a big data lake. Do I need to pull all that data into Oracle Cloud Planning in order to do these type of predictions? And are there any existing frameworks? And I'm going to apologize. I'm probably going to stop right after we do this next topic, and then I'll open up a future conversation to talk about the framework. Here is a conceptual architecture that I would recommend as you're thinking about what Oracle is actually calling, we heard it earlier today with Hari and with Matt, intelligent performance management. No, you do not want all of the data that you can find in a data lake ported into your planning models. Our whole life, for the last 30 years, I think Edward would probably, hopefully agree with this, we want planning models that are very lean, that meet the very specific requirements to create a financial forecast. We don't want to start pulling in all of the world's data into a plan application just to create predictions. So in order to prevent overload of your planning application, you need to marry in a couple of middle layers, which you already have. One is a transformation layer of, hey, how can we start to take those various data sources, structured and unstructured, apply it to our metadata governance that we already have, DRM, EDMCS, and bring that together so that we can create our own prediction layer. And I'm not going to drill through this, but I like to call this prediction layer the dog's breakfast. If you're familiar with that term, it could be anything. All of these tools mean something to everybody. Tools to automate your predictions are Python, SAS, if you're in that world. More advanced capabilities such as Alteryx. I would be remiss if I didn't mention C3 AI, which is closely related to Baker Hughes, has some prediction layers at the operational layer. We looked at Jump. And then all the libraries that you can use, such as Pandas, NumPys, TensorFlow. TensorFlow is really good at building machine languages so that at the very end, you can automate engines and you can spin up prediction engines using Docker or Kubernetes and That's where it really gets cool. I'm going to create another follow-up presentation to this that gives you more of the predictive layer capabilities. This is a lot. This is giving you 45-minute masterclass that should actually be about 3 months long, but we're not going to take that long. But this is how you start to think about how you create conceptually the architecture needed to bring in those various data sources. And then into your Oracle Cloud Planning application, if you've constructed it using the theory of drivers, driver-based planning, your predictions become inputs to the drivers. And then you can create different scenarios that capture those inputs and say, here's the machine as the machine predicts the data, and here's the human input. You can do scenario analysis. We do it all the time in actual versus budget. Hey, how can we see what's good and bad? Is the machine better than the person? You'll get some interesting insights through that exercise. I'm going to skip this analytic lifecycle. You'll get this in the presentation. I'll create another presentation specifically around it, but it's an orderly fashion for receiving your ideas, defining your strategy, acquiring resources all around to communicating results. The takeaway there is that it's a continuous improvement. It requires a continuous improvement mindset, and you need to ask yourself, are you asking the right questions? Do you have the skill sets and the tools in place to conduct this analysis? And does it help you improve your confidence in your predictions? So let's wrap it up. The traditional finance roles, the definitions that you have for a finance professional is evolving, should evolve to create that new role as I described, the finance analytic professional. Second, your culture of analytics in your company requires commitment at all levels of the organization. From the top, they need to be committed to investing in and in both people and technology, improving their analytic insights and their predictive capabilities. And that life cycle that we breeze through in about 2.5 milliseconds, it's not rigid. You can create one yourself, and you can make it flexible to meet the needs of your organization. That one was actually created for a nonprofit organization, and I retrofit it. But here's the takeaway. Arthur Nelson, founder of AC Nelson, said the price of light is less than the cost of darkness. And so that's my takeaway for you today. We'll go to question and answer. We're almost out of time with Q&A. So I'll bounce past you. If you really want to be able to talk as nerdy as I just did, contact Myra or Javier at Texas A&M. This is the Mays Business School in Houston classroom. I'm not actually here, but virtually I'm here, and you can get more information about this program. It's wonderful. So that is my presentation. Let me go to the Q&A and see if there are any questions. How should we deal with the sharp COVID volume impact and comeback that's in our historical data? So you heard about it today, described as a rare event. So in data science terms, COVID, 9/11, stock market crashes, they're rare events. They're very difficult to predict those rare events. However, you can learn from the impact and the kind of the shockwave of a rare event. And that's where the lesson is. So Bill, this is a really good question. How should you deal with sharp volume impacts and comebacks? I'd love to take that question offline. If you connect with me on LinkedIn, we can keep that conversation going. In summary, Tracy, great question. Predictive analytics in Oracle EPM is good and works. Yes, it works, but it's always based on the quality of the data that you're putting into your EPM application, into your planning application. So garbage in, garbage out. Same rule applies. Anyone else? No open questions. Thank you very much for attending. I hope you have a wonderful solutions conference. Thank you again, Edward, Robin, the whole team at NRL for allowing me to ramble through this presentation really super quick. And connect with me on LinkedIn. We'll continue these conversations. Thank you very much. Have a great day, everyone.